property of Captain Whitebeard. Bowen, are you busy right now? Can you help me real quick?
Dude, no, I gotta work on my essay, man.
No, Bowen, come on, look at this. Look what I found. It says property of Captain Whitebeard, and it looks like some sort of treasure map. And then there's some sort of like tiny P written down here of like X and Y. I don't know what it means.
Dude,
Can you, like, help me figure it out?
I saw one of these in my calculus class. This is one of those density equations. I remember
Density.
it was pretty hard for me to get it on my midterm, but I think we can solve it together. Maybe the center of mass could be where the treasure is.
Oh yeah, that center of mass of the school?
Of the school. Oh, we got this. Time to solve. Okay, so you start by writing down the equation. Rho of xy equals x squared sine squared y. So you gotta find the x bar and the y bar, which is
the what?
X bar and y bar. That's the center of mass. You take the coordinates. So x bar, you just take the density function and you integrate from 0 to 1, because our map shows that it's from 0 to 1 mile. You get x cubed sine squared y dx dy.
Hey, why is it x cubed and not x squared?
Because you got an added x for the x hat. Otherwise it's just the same thing. So you get x4 over 4 and go from 0 to 1. This becomes 1/4 sine squared y dy. Here's a little trick I memorized. Sine squared y equals 1 minus cosine of 2y over 2. It's a little quick substitution. So you integrate y minus, this becomes sine 2y over 4. 1, 0, 1 over 4, 1 over 4 of 1/2 minus sine of 2 over 4 minus 0 over 2 minus sine of 0 over 4, which is 0. So 1/4 times 1/2 minus sine 2 over 4. There we go.
Ooh, are we done?
Then you gotta solve for the y bar one. Okay, Albert, let me just get another piece of paper for the y bar. Let me calculate it real fast here. Okay, so it's like the x bar one, but you have an extra y. So x squared y sine squared y dx dy, integral from 0 to 1. So you integrate x squared, it becomes x cubed over 3, and then you put the 1/3 in front. And you do the same trick with the sine squared y as I did last problem. Sine squared y equals 1 minus cosine 2y divided 2. I take the 2 and I put it in front, and it becomes 1/6, so I don't have to deal with it right now. You distribute the y. It becomes y minus y cosine 2y. You split up into two parts, y dy and y cosine 2y dy. And then you apply integration by parts for the part on the right. So if u equals y and dv equals cosine 2y dy, du equals dy, and v equals sine 2y over 2. So integral of parts, you get uv minus integral from 0 to 1 of v du. So you get y sine 2y over 2 from 0 to 1, and the integral of sine 2y over 2 from 0 to 1.
Right.
This becomes sine 2 over 2, and this becomes cosine 2 over 4 minus 1/4. So when you, and the y squared over 2 becomes 1/2. When you put it back into the equation, you get you add 1/2 and 1/4, so it becomes 3/4 minus sine 2 over 2 minus cosine 2 over 4. And then you pull out the 1/4, so it becomes 1/24 times 3 minus 2 sine 2 minus cosine 2.
So according to the x bar and y bar, it should be at, hold on, it should be at, I think the treasure's gonna be at Royce.
Oh, that's clever. He's a math pirate, puts the math treasure in North Campus. Okay, we should go there tomorrow morning, and then we'll split the treasure 50-50.
60-40.
Oh, yeah, 60 for me, 40 for you.
Oh, what?
Let's go.
Sorry, I'm late, Bowen.
What took you so long?
Oh man, I think a nap. So according to this map, it should just be right around the corner in some like dirt patch. I don't know.
Okay then, you ready to get this treasure?
Yeah, I'm so ready.
Let's go. Okay, I think the treasure should be around here. Wait.
No! Dude, what was that?
What did we do wrong, Albert?
I think that was like a booby trap or something. I think we did something wrong.
Dude, I heard of this really smart math student,
Nick, I think we should go see him tomorrow to see if he can double check our math. Work.
Alright. Hey Nick, can you help us with this center of mass problem? Because I think we did something wrong and it like almost got us killed. So take a look at this.
Okay. I see what you guys did wrong. You just forgot to divide by the mass.
Wait, why would we need to divide by the mass?
Here, let me show you. Okay, so let's consider a one-dimensional case where you have let's say a bar going across here on the x-axis from point A to B. We know that the center of mass is going to be at a point like right here, x bar, and we're going to be going across some arbitrary point like point X right here that has some mass. We're going to know that infinitesimally small mass from the density function, rho of x, which I see that you have one. So let's see. So the sum of all torques about this point is going to equal 0. And then we're going to be of the density function times the distance across, which is going to be x. We're going to bring this all over here, so we have a to b, x bar rho of x dx equals a to b rho of x times x dx. Divide, so we just get x bar, and we find that x bar equals a to b rho of x dx. And finally, x. Notice that this here, integrating across a to b of rho of x, is simply the mass. So all of that divided by the mass. And yeah, you guys did the hard part. Now it's just do the easy part.
Alright, so let me just solve for the mass. Alright, so the mass should then be the double integral of from 0 to 1, 0 to 1 of our density function x squared sine squared y dy dx. And let me just split this up. And this is just equal to 1/3 x cubed from 0 to 1. And this I could rewrite as 1/2 minus cosine 2y over 2 dy. And the first part just becomes 1/3. This part becomes, y over 2 minus sine 2y over 4 from 0 to 1. It becomes 1/3, and this part is just 1/2 minus sine of 2 over 4. And that should be the mass. Alright, so Bowen, I guess you just need to take the x bar and y bars you got before and divide it by the mass that we just got.
Oh, according to my calculations, instead of the treasure being at Royce, it's actually at the Garden of Statues. Okay, this is pretty big. I wonder what kind of treasure we can find. We should probably take a day to prepare so that in case it's booby trapped like last time.
Alright, this is it.
Okay, Albert, this better not be booby trapped.
Yeah, or I'd kill Nick.
If we
don't die first.
We're all in now.
Yeah.
Let's hope this treasure was all worth it.
Oh my gosh, can't wait. Wait, could this be it? Alright, Bowen, are you ready?
I'm ready for this.
3, 2, 1.
Is that what I think it is?
Oh my god.
Dude, this is gonna help us out in math class so much.
It's beautiful.
I can't believe WhiteBeard would have something like this. Okay, we can't tell Nick about it.